In this short video, I introduce you to the Gong Shuttle Passenger Ecosystem. Within this system, we use a range of wireless technologies to communicate with what we call a digital bus. The simplest idea of the digital bus is a system where a passenger can request and receive information about their current transport options at a given location. Digital passenger information systems have existed for some time, on the London Underground or the Metro in Paris, but in these environments there's a single integrated transport authority, so the delivery of the digital information is relatively easily done. Integrated information environments are more difficult to implement when combined across multiple companies, transport types and providers. In the digital bus, connecting services, details of the next bus or train, local shops, businesses, hotels and other traveller-related information are made available via GPS, wireless networks and personal mobile devices, as well as in traditional forms such as signage and audible signals. In return for this information, passengers provide details of their trip, their starting point, their destination and their current geolocation. These microtransactions are stored and used to optimize overall transport system behaviour. The technical challenge is capturing this information in a ticketless environment. This is the reason that a free shuttle service is the focus of our study, but the results can equally be applied to variable road pricing systems involving private vehicles, which are of course also ticketless. Individual passenger trip information can be used to leverage efficiencies in a transport system. This allows a transport provider to optimize resources and maximize passenger comfort, safety and throughput. At an operational level, it allows the transport provider to dynamically plan peak and off-peak demand cycles. At a strategic level, the transport provider can better plan the acquisition and maintenance of its vehicles. At a tactical level, the platform allows transport providers the ability to experiment with different routes and new transport options. For these reasons, and others, we characterize the Digital Bus project as a digital ecosystem. A digital ecosystem is a distributed, adaptive, open socio-technical system with properties of self-organization, scalability and sustainability. The idea itself is inspired by natural ecosystems. In a digital ecosystem, various interrelated components are considered as a whole rather than individual subsystems. System behavior is in part dictated by the quality of the information provided via its interacting agents, in this case passengers, buses and bus stops, and system convergence occurs via patterns of usage. This enables the realization of greater value from each subsystem as a digital ecosystem becomes progressively more predictive and more useful than the sum of its parts. So that's the theory. Let's ask, how does it work? The core of the system is tracking the GPS coordinates of the transport vehicles. Whether these be buses, trains or light rail makes little difference, but our proposed experimental platform is the Gong Shuttle, a 36-stop, free loop bus network in Wollongong, New South Wales. The Gong Shuttle has a supplemental Route 9 service, a free bus that connects the North Wollongong Railway Station and the University of Wollongong campus, and in doing so interconnects with Gong Shuttle destinations. The Gong Shuttle environment is chosen because it's local, it's ticketless, it's untimetabled and relatively simple. However, the ideas are intended to be scalable to much larger transport networks. Let's first consider a passenger with a 3G phone, like an iPhone. In this case, the passenger can install an iPhone app with a map of the Gong Shuttle network. The iPhone has a GPS, so the application will be aware of the passenger's location. It contacts the web-based bus GPS server over the 3G network to find out the location of the nearest bus and how and when the passenger should arrive at the stop to catch it. When the passenger is on campus, they access the information via the campus Wi-Fi network, when off-site via the 3G network. There are a host of tertiary services around this idea. A smart travel assistant can be added to the passenger's Outlook calendar so that they can be alerted and directed to a shuttle bus to arrive on time for a meeting. Naturally enough, not all passengers are that well organised. Many just arrive at the nearest shuttle stop in the knowledge that a bus will come along within 15 minutes. Usually the arrival time of the next bus can be displayed at the stop or reported by an audible announcement. For wireless-enabled passengers that join the bus, each bus is a wireless hotspot, so if their wireless device is switched on, they can access the internet on the bus. By proxy, this is a mechanism used to capture specific trip details, the passenger's de-identified ID, where they joined the bus and at what time and where they got off. This information is stored in order to model the network, optimize schedules and resourcing for drivers and vehicles. It's also a handy security and safety aid. But still in 2010, not everyone has a wireless portable device. Many people still use GSM phones, for instance. For these passengers, they can SMS a 1-800 number and get a return SMS with the arrival time of the next bus at their stop. They can make this inquiry from their school, from the office, the beach, or from the stop itself. The same GPS bus web server provides information via an SMS gateway to the internet. Speaking of the office environment, the Andrews Corporation is a partner in this research project, and they have a location-based IP server technology that's a fantastic way of knowing where potential passengers are when they're located on the campus. Because the campus is large and there are many points at which to join the shuttle network, a web-based client, analog to the iPhone app that I mentioned earlier, is used to locate the passenger via their desktop IP address and then track that location relative to the bus. As well as a full-feature map-based website, RSS feeds can be used to give alerts, or at a more tertiary level we also build what are called widgets for the Mac OS X or gadgets for Windows that are in effect mini RSS readers. The research team have always been conscious of the fact that not everyone has a mobile communication device. We can't and shouldn't assume that everyone has a mobile phone, for instance. This leads us to think of using multicast digital FM and the idea of using RDS, the radio data system, to add data about the next bus to the baseband signal of a local radio station. The idea of multicast RDS is, as far as I can tell, a new idea, but if it can be solved, it can not only be used to multicast bus information to passengers on an individual basis, but also to the stops themselves. We propose a shuttle radio, an MP3 radio device with a small LCD display that can be used to receive and display the latest bus arrival times at any given stop. Finally, we wanted to incorporate some fault tolerance into the vehicle tracking on the digital bus project and ensure that it was extensible so that it could accept eventual information about traffic flow and density. To this end, we proposed the use of DSRC, or Dedicated Short Range Communications, to triangulate the GPS signal tracking the bus. Each bus would have a DSRC tag, and each stop, or some of the stops, would have DSRC readers. Since the DSRC operates in the same radio frequency spectrum as E-tags, which are broadly used in New South Wales, we think this is an obvious extension to allow us to experiment with the idea of a national variable road pricing system. In summary, the challenges of capturing passenger trips in a free transport network, even a small one, are the same challenges faced by a much larger ticketless public transport network or by a national variable road pricing system. Although we don't have the solutions for all of these issues, capturing passenger trip data is a multi-channel, multimodal problem. I hope you'll agree that the digital bus idea is a nice platform on which to research these ideas.